So after seeing DoTween, you might be thinking, well, that's it, tutorial over. That thing is fantastic and it's very useful for all sorts of things, so good times. And you're totally right. Hey everyone, my name is Pablo, this over here is Milo, and today we're going to do a tutorial on interpolations. So an interpolation is basically just going from value A to value B over a period of time. But it truly is one of the tools that I use the most as game dev, mainly because you never want things to just like pop into place, because that looks really sort of robotic and not polished. You generally want, some smooth movement in between things. So basically what we have is this little pad over here, which you can see a little bit of energy around it. When we stand on it, the energy comes up and then we get the little call out for press X for the door, and then if we press X, the door goes down. If we press X again, the door goes up. As you can see, it's pretty rough. As I stand on and off the thing, it just appears. It doesn't feel particularly good. And obviously the door just kind of snapping open and close is pretty horrible. So I'll give you a quick tour of the code. Over here we have a game object for the effect, a canvas group for the UI hint. Canvas group is one of the UI classes that is used to group elements of UI. Then over here we have an event, which is on trigger, so that we can do whatever we want when the pad is triggered. And over here we keep track of if it's active, and then we just decide what the inactive scale and the active scale are going to be. This is to modify the effect. And over here we calculate them, which is essentially for inactive use the one that it has by default, and for active just scale it up a little bit. And then in the update we say if it's active, so if we're standing on it and you press the button use, which in this case is X, then invoke the event of trigger. And over here we just have three functions that are connected, which is basically if you enter the trigger, set active to true. If you exit the trigger, set active to false. And where we're setting the active, we're basically just setting the bool, and then we're setting the local scale of the effect to the correct one, and the same for the alpha of the UI hint. So what exactly is an interpolation? Essentially, it's when we have a value A and a value B, instead of going directly from A to B, we interpolate between the two numbers. So as you can see there, it's essentially we're traveling between the two so that the transition seems smoother. Another common term for this is tween, which comes from in between, which I kind of hate. So I just call them interpolations. So we're going to cut this out of the set active and move it into the update. And then instead of just setting to the value, we're going to use a lerp. So vector3.lerp. And we're going to go from effect.transform.localScale and into the value we already calculated before. And we're going to give it time.delta. And let's multiply it by, let's say, 2. And we're going to do the same for the hint, but this time mathf.lerp, since this is a float and not a vector. And in here we're going to use UI hint.alpha. For our target value, we use the one we already calculated before. And then we also give this time.delta time times 2. So let's give that a test. Now you see when you get up, the effect grows slowly and the X appears slowly. And then when you step out, they do the same. And we can tweak that scale. Right now we just put it to 2, but we can make that faster. It does feel like it needs to be faster. Okay, so now we change the speed. Let's try it out. And that feels better. It is faster. It still feels a little slow, but it'll work. If you've seen any of the other tutorials I made, I actually use this style of interpolation quite a bit. It is really useful, but it's mostly useful for one case in particular, and that's for values that are constantly changing. So for example, for the movement of the head, I use that interpolation because it is constantly responding to user input, so you're always trying to catch up to a certain value. But in the case of this, which we only do when you enter or when you exit, it is actually pretty wasteful because even right now, as it's not moving, we're still running the update cycle and it's still changing the scale and the alpha of that group. Even though nothing is really happening, we're still changing it. And there's two other big downsides to this style of interpolation. So one of them is that essentially what it does, it's trying to get from A to B, but for that it just chooses a point in between. So there's the Xenox paradox. It's called the something something paradox. I cannot remember the name. But basically what it says is that to get from A to B, first you gotta go at halfway. And then from there you gotta get halfway. And then from there you gotta go halfway. And then halfway, and then halfway, and then halfway, and then halfway. And since it's forever halfway, you never actually get to the end. So for example, here, if I look at the alpha, I'm trying to get to 1, but as you can see, it keeps going and going and going. And now this is as much as it can represent to me. But it never actually got to 1 because essentially of the paradox. In this case, we are literally falling into that paradox. And then when I go out, you can see it becomes smaller and smaller and smaller and smaller. And it keeps trying to get to 0, but it's not quite getting there because we keep going just part of the way. Like the values that it's going right now, minus 26 exponential, it is essentially 0, but it's still recalculating every frame. So, you know, that's not so great. The other downside of it never actually getting all the way to the value of B is that it's very hard to make callbacks based on it finishing its interpolation. Because when does it really finish? It never really gets to that value. So what you end up doing sometimes is to say, well, if you're like within 0.01 of the value, then call the callback. But then you have to add other safety checks like saying, okay, well, now that you call the callback, make sure you don't call it again because next frame you'll still be within 0.01 of the value. So it just complicates things. So really, I try to use this interpolation just for one case and one case only, and that is values that are constantly changing based on either user input or the weather or constant motion by another object. Things like that, things that I know that will be updating every single frame, and therefore it's fine for me to be updating all the time. But if you're gonna trigger an interpolation based on an event, such as getting on a plate or opening a door, things like that, it's much better to have an interpolation that just runs once and then it's over. So let me show you how to do that. But before we do, if you ever want to watch more of my face, you can come to twitch.tv/PabloPoon. I stream there every Monday, Wednesday, and Saturdays, and I hope to see you there. So you might be wondering, if that's not the right type of interpolation for this, what is? And for that, we're going to use an asset from the asset store. It's called DoTween. We're going to use the free version. It has many bells and whistles, so you can probably do anything you need with this. But I would recommend, if you really like it and start using it a lot, to buy the complete version to support the developer. The link will be in the description. So now go to your package manager, and under that, select my assets. So here you just search for DoTween. In this case, I'm going to use the free version. And then when you say download and import, then you'll get a little bit of a setup process. It's pretty straightforward, so just follow up the instructions there. Once it's done, you can check out the documentation if you want. That's pretty useful. And back in our code, at the top, we can add a using dg.tweening. Then from our update, this is where we're scaling our effect. So let's comment that one out. So instead of putting it in the update so it happens every single frame, we're just going to put it when the event actually happens. So that way it will only run when it needs to run. So for that, we're going to say effect.transform.doScale. And in here, we're going to pass essentially what we had here, which is if it's active, then active scale, otherwise inactive scale. And then we're going to pass a duration. And in this case, we're going to tell it that we want it to last half a second. And now when we get up, as you see, it's scaled just fine. And now it's not running every single frame. However, our hint is still doing it. So for that one, we called UIHint.doFade. And just like we did with the other one, we're going to pass this thing over here. And we're going to pass 0.5 as well, so half a second. And let's comment it out from here. And now when we get up, it fades in. When we get off, it fades out. And if we do the check we did earlier, just to see the values, when I get up, it goes all the way to 1. When I get down, it goes all the way to 0. It doesn't stay there trying to get to that value forever. So now let's make the door also interpolate. And for that one first, the first thing I'm going to do again is using dg.tweening. And then over here, I'm going to expose public ease. And then I'm just going to call it easing. And then public float duration. And let's make this actually open duration. And it's set open, we're doing something very similar. We're essentially just changing the position based on if it's open. We just put it in the open position or we put it in the closing position. So we can easily change this to use the tweening now by saying do move. And then we just use those values, and in here we pass the open duration. And then to pass the easing, we just do a dot set ease, and then we pass easing in there. So we stand over here and then we press X. You can see it moves down and then moves up. So right now the door is moving at a constant speed, which is also called a linear movement. And the reason you don't want to do that most of the time is because if you think of real life, if you have an object that is going to start moving, generally there's like a period where it accelerates to reach its maximum velocity. And also if it's going super fast and then it wants to stop, there's like a little period where it has to slow down, because otherwise it'll have momentum from its speed, right? So that's the reason you don't generally want to do linear animations, because they tend to feel very unnatural. So you'll be able to choose between many different types of easing. DoTween actually has over 30 different ease types. I'm going to show you some of the basic ones right now. So linear, at the very top, as you can see, it's a constant rate. You can see the little dots are spaced out evenly. Then ease in starts slow and then accelerates over time. Then ease out is exactly the opposite, starts fast and ends slow. And then ease in out is basically starts slow, goes fast in the middle and ends slow. So let's try some of these on the door. So over here, we're going to select from, as you can see, there's many types of easings. Let's give a try to out elastic. So I press it. You can see that was kind of crazy. You can just sort of see it bouncing. That is because it's super fast right now. So let's make the duration a little longer so we can see it more clearly. 2.5. And there you go. As you can see, it is moving. It's just doing like a elastic bounce at the very end, which obviously doesn't really match the movement of a door very well. So let's try out cubic, which is very similar to the one I just showed you before in the demo. That one was an out quad, as in a power of 2. Out cubic is out in a power of 3, so it's even a little more pronounced. So then when I go and press X, as you can see, it starts slow and then it speeds up as it goes. So as you can see, just by changing the easing, you can really change kind of the feel of any motion you have. A couple other cool things that you can do with DoTween that are very useful tools. You have an incomplete event, so you can from there either trigger another interpolation or maybe trigger a particle effect or a sound or all sorts of things. And also you can just at the end do dot set delay and then pass a number. So that way you can say, oh, I want this interpolation, but I don't want it right now. I want it in half a second. So you just do dot set delay 0.5f. So after seeing DoTween, you might be thinking, well, that's it, tutorial over. That thing is fantastic and it's very useful for all sorts of things. So good times. And you're totally right. So since DoTween is so amazing and I'm telling you should use it, why is there more tutorial, you might be wondering? And the reason is because I wanted to show you how to make your own interpolator. And that's not because I think we're gonna make in 10 minutes an interpolator that's better than DoTween, but I do think you can benefit from knowing sort of the inner workings of an interpolator so that you can get a better grasp of what it's doing. And also along the way, I'm gonna show you a couple C# tools that are very useful in general. So let's create a script and we're gonna call this one Interpolate. Let's get rid of this part. So let's start with declaring a bool, initialized, and let's set it to false. And we're going to declare a couple of variables here, float duration and float life. Duration is how long the interpolation is going to take. Life is how long it's been since we started. So let's declare an initialize function, and for that it's going to be public void initialize, and we're going to pass as a parameter the duration that we want, so float p duration. And inside of it, we're gonna set duration equals p duration. Then we set the life to 0, and then we mark the initialize flag to true. And the reason we have this flag is we don't want the update to be running until we have it called the initialize. So in here, we're just going to say if initialized, and then that is basically what's going to condition all of our other logic. Here we're going to say life plus equals time.delta time, and then right below we're actually going to clamp it. So basically we're going to say life equals math.min, so the smallest number that we can find between two numbers, and that's going to be life and duration. So we never want life to go further than duration. And then right below we're going to declare float proportion, and this is just going to be life divided by duration, which essentially means, let's say that our duration is 1 second and our life is been 0.5 seconds. We're at essentially half our life, so our proportion would be 0.5. We need to do something with this proportion. For now, let's just put a little comment here, and we're just going to say to do something. And then we want to check if our interpolation is done. So basically, if life equals duration, you could also just check if proportion is 1. Then inside of this, we're going to do a couple things. One, just a to say do something when you're complete. And then we're going to destroy this component. So basically, once it runs and completes its interpolation, it destroys itself. So what are we doing here? Really, all we're doing is changing a value from 0 to 1 over a duration that we specify. And that's it. So besides just showing you how you can make an interpolator, I also wanted to do this to show you a couple of very useful techniques in C#. And the first one of those is delegates. So delegates are essentially like stand-in for a function. So for example, if you declare a function that returns void and takes in a float, you can then pass in any function whatsoever from any class that has that same structure. So in this case, we're going to declare an interpolation delegate, and it's going to return void, and it's going to take in a float. And basically, in there, we can just swap in whatever function we may want in for that one. And while we're at it, we're also going to create a second delegate here, and this is going to be a complete delegate for when the interpolation is done. And this one is going to take no parameters, and it's going to return no type. And then in our class, we can declare interpolation delegate on update and complete delegate on complete. And in our initialize method, we can take a parameter for each one of them and then just save it to the local variables. And let me show you how easy it is to use this. So basically over here, we're just going to say on update, and then we're going to add a question mark, which is basically just a null check. And I'm going to say dot invoke, and invoke is what's going to call the actual delegate, and in there we're going to pass in proportion. And we can remove this comment now. And we do the exact same thing on the life equals duration check, except this time we call onComplete and then we call invoke. This time there's no parameters, so we just put the parentheses and a colon. So what this means is essentially every time we update, if someone set a delegate for us, we're going to pass in the proportion into it. And if someone set a delegate for complete, we're also going to invoke that one once the interpolation is complete. The second technique that I really wanted to show you from C# is called class extensions. Class extensions are a way to basically add a method to any class. For example, in this case, we're going to add an extension to Unity's game object. So let's declare over here a public static class, and you can name it whatever you want. I like always naming this class something extensions. So in this case, I'm just going to call them interpolate extensions. And then to declare the actual extension, we go public static void interpolate scale. That's what I'm going to use in this case. And then we say this game object. That first parameter is what's going to determine what the extension is extending. So in this case, it will extend game object. And then we can pass in whatever parameters we want. So in this case, I'm going to say vector3, and then I'm going to call this p target scale. And then I'm going to also ask for a float, and this is going to be the duration. So basically, this little extension is going to be declared on game object, and the coding here is what's going to create the actual interpolation object. So let's just save our local variables. Let's just set transform trans equals pGameObject dot transform, and that's just for ease of use. And then we're going to say vector3 initial scale is going to equal trans dot local scale, and then we're going to say vector3 delta scale. so how much is the scale actually changing, is going to be target scale minus initial scale. And then right below it, we're actually going to create the interpolation object. And the way we do that is we just say interpolate. In this case, I'm just going to call it interpolate component. And then I'm going to say equals pGameObject dot add component. And then the type I'm going to pass in is going to be interpolate. So that's essentially just creating a component, the component that we created above. It's adding that component to the game object. And then I'm going to say interpolate component dot initialize, which is the function we declared above. And in here, I'm just going to pass the duration from our parameters. And then I'm going to pass in a delegate. So I'm going to say delegate, float, proportion. And then I'm going to pass a null because we had another delegate there for the complete. And for now, we're not using that yet. So what we're going to do in here is actually very, very simple. We're just going to say trans.localScale equals initial scale plus delta scale times p proportion. And p proportion, if you remember from where we were doing the update, is just a value from 0 to 1. So in this case, we're saying, oh, from where you started, so initial scale, then multiply the delta, how much you're changing, by that value of 0 to 1. So it's actually pretty simple. I know it looks like a lot of code, but it's actually pretty simple. And then we go back to our trigger. And here where we're doing the do scale, which is from the DoTween library, we can just comment that one out and then do effect dot interpolate scale, which is the extension we just declared. And that's it. It should just work. So we'll give it a test. Once we get in the platform, as you can see, the effect is still interpolating. And then if we go back to our code, we can do the same for the little UI hint. So we just go back to where we declare our extension. And then let's just copy paste this. I'm gonna kind of rush through this one because it's basically just a copy paste, and then we just gotta rename it into interpolate fade, and then change from game object into canvas group, which is the thing that we're fading, and then just change everywhere that says vector tree into a float because the alpha is just a single float. So as you can see with this, we can very easily extend the interpolations to apply to whatever different class we need and the different, property that we want to modify. It's very easy here to just basically add any that you might need. Then we go back to our trigger code. We change do fade into interpolate fade, and that's it. So now we get in, as you can see, the little hint fades in and fades out, and the effect grows in and grows out. So excellent. The animations are linear, and like we discussed earlier, linear animations are not exactly the best. So I would recommend that if you want to keep on expanding this, you could try adding some easing to that, and there's a very easy way to do that. Here's a GitHub for an easing library visualization, and he has an implementation in there for all the easing functions that he's showcasing there. They're based on the original Robert Penner ones, which are really, really old, just like myself. I actually remember using this like literally over a decade ago. Oh God. So from here you can just download the CS file. It's actually pretty easy to plug into that interpolate thing that we made. If you want the code, just let me know in the comments and I can share it with you, because it's actually pretty trivial to hook them up. So that's it for interpolations. I use them all the time, be it gameplay, UI, effects. They're useful all over the place. I really recommend you kind of start using them. I would also recommend that maybe from the Interpolator that we started doing, maybe finish the incomplete event that we didn't finish, maybe add a delay. Those can be very useful. They're kind of simple things to add that you can use for practice. Anyways, I hope you were entertained. I hope you learned something. I'll see you on the next one. Adios.
Well, thanks for stopping by. Don't forget to like, subscribe, and hit the bell to be notified when new videos come out. Thanks for watching.